Hello everyone. Today we will talk about three very important and basic concepts in the math and statistics area. The first one is histograms. The second one is about distributions. The third one is normal distribution. Let's first focus on histograms. Why we need this? I think it's as an example, we measure many people's their height. Some are short, some they are tall. Because we collect so many data, and it's hard to see, some of them they just overlap here. But if we divide the height by different bins, then it can help show us a little bit clear view. So for example, more people are landed in this area, this kind of height, and less people very tall, and also not many people that short. So majority, they are mainly in this kind of area. So this brings to another topic. The width of the bin is very important. If the bin is too close to each other, then still we cannot see a very clear distribution there. And if the bin is too big, still it didn't provide too much information here. So ideally, if we cut the bin very good, then we can see some clearly kind of distribution here. The blue line here just demonstrates the high-level outline of the distribution. And the different kind of sampling can give you different kind of distribution. For example, the first one, we call it a normal distribution. And second one, we call it exponential distribution. It just demonstrates different kind of stuff. And now we'll talk about what is distribution and why we need it. So for example, we'll collect a lot of information here. So how about this range? We do not have any information about it. How can we estimate it? So if we have a distribution, then we can use that to calculate the probability of people with this kind of height, how many will be there. And it can also have another advantage, that is the curve is not limited by the width of the bins. So sometimes the bin is too big, they may miss some information. Sometimes the bin is too small or not exactly same width as we wish for. So we can use this method to get the right kind of bin width or any point you want to estimate the view. And the third part is that if we don't have enough time or money to get enough samples, then we can use this distribution to get approximate information. It can be good enough for some preliminary understanding of the data. Now let's move to one of the most commonly used distribution, which is normal distribution. As you can see, it is like a bell curve, have a tail and it goes up and down. The y-axis is presented the relative probability observing someone who is really short or really tall or has an average height. So it's about the probability. And you know, like for this curve, it can have different attributes. Some of them, they may be very sharp and tall like this one. Some may be flat. So for example, this one is a distribution of the babies. Not too many babies are born so differently, right? They have some average height there, and they don't vary a lot. But for adults, when people grow up, the distribution becomes wider, and people, some are very tall, some not that very tall. So for this one, we can see, like for example, the mean is different, and the 20s and the 70s. Also, the standard deviation is measuring the width of the curve. This one is very narrow, very sharp, so it's 0.6. This one is flat, which is 4. So by knowing those, the standard deviation is very helpful. Because for the normal curves, we know that about 95% of the measurements falls between the plus and minus 2 standard deviation around the mean. So in this example, we can make the conclusion that for those new babies, we are 95% of sure the baby's height or length can fall between 20 inches plus and minus 1.2 inches. 1.2 is 2 multiplied by the standard deviation, which is 0.6 here. And same with the adult, we are 95% sure that the adult's measurement, like their height, will be between 70, like the mean value, plus minus 8, which is the 2 multiplied standard deviation. 2 multiplies 4, that is 8. And also, because the distribution is different, we can also make the conclusion like that there's a high probability of measures a newborn baby boy within 1 plus and minus 1.2 inches of the mean. But for people who falls within same kind of width, for the adult, the probability will be lower because their areas under the curve, which shows their probability is smaller. This one compared with this one. And to draw a normal distribution, you also need to know like the 2 elements. One is average, which tells you where the center of the curve goes. Another one is the standard deviation, which measures how wide the curve should be. And the width of the curve determines how tall it is. The wider the curve will be shorter, and the narrow curves, the taller. So those are the basic concepts about histograms, distributions, and one of the most common distribution, which is normal distribution. Thank you for watching. Bye.